Okay, year 11, we'll have a look at drawing this diagram. This is on page 8 of your notes, and it's how you draw plane wave reflection, and this is very typical of the type of question you could get to do in an exam. Now, as I say, you've got to do this with a ruler. What I'm going to do is I'm going to draw this without a ruler because I haven't figured out how to use a ruler on this software package yet. But when you come to do it, if you use a ruler. So the first thing to notice is you're very often given a diagram which is only half complete and you're asked to complete it. So we've got at the bottom here a barrier, and then we're shown 3 plane waves, 1, 2, 3 there, and they're traveling along in this direction. So first thing I'm going to do is take that direction of travel and draw it until it hits the barrier. So this is a straight line, should be done using a ruler, and it shows where those waves would hit the barrier. It's going this way, and that would be 90 degrees there. So those 3 waves are going to go along, hit the barrier, and be reflected. So what I'm going to do next is at this point draw a normal line on, and then I'm going to use a protractor. You can't see this, but I'm going to use a protractor to measure this angle, and that's the angle of incidence. Now say that's 30 degrees. That means the angle of reflection is 30 degrees. So that means I draw the direction of travel after it's reflected goes on the right hand side, and this angle R is the same as the angle I. They are both equal. Now I have to draw these 3 waves. So these 3 waves, 1, 2, 3, they kind of come along here, they hit the barrier and they're reflected that way. So you've got to draw them so that they look the same except they're going in a different direction. So there's one there. Now the wavelength is the distance between 2 wave crests, which on this diagram is that distance there. That little distance there is a wavelength. Now that should be the same after reflection as it is before. So I'm trying to keep that little distance there. The wavelength is the same there as it is here. And it's the same on that side. Also the size of the waves, so the way they've been drawn from one end down to the other. So the size of the wave should be the same on both sides of the diagram. So don't draw one of the waves over here on the right. Draw it really tiny like that, really enormous like that. So neither of those would be good. It just has to be the same size as it was before, the same wavelength. There's 3 of them, and we still have that nice 90 degrees between the wave front. This line here is called the wave front, between the wave front and the direction of travel. Now what I'm going to do is I'm going to draw this out on a page properly using a ruler, and then take a picture of it, and then you can have a look at that and make sure it's right in your notes. The diagram on page 8 is quite an important diagram.